No, I did not say that. I was like, are you sure you're good? I was like, are you sure you want to say that?
Okay, we're on page 24, but I want to review a little bit with kind of like the parent function and the y values that goes along. With parent function. So I have a little chart here. For sine, we know sine, where does the sine start for its y value? Yep, 0. Okay, and then moves up. Okay, and we know that goes with sine as well. Oh, sorry, cosecant as well. But we know that with cosecant, there's going to be vertical asymptotes, but we can draw those in after we have our see where it intersects with our d value. Cosine, where does cosine start? Has a y value of 1. Yeah. Okay, so secant matches up with cosine. Cosecant matches up with sine. Now, cotangent is a little bit different because at the edges we have undefined, which are vertical asymptotes. And where does cotangent start? Yeah. What y value does it start at? Cotangent? 1. So something that I used that may be helpful is cotangent and cosine, they both start with C, so they both start at the same height. They both start at 1. So maybe that will be helpful to help you remember the difference between cotangent and tangent. So, but cotangent only has negative slope, so it starts high and it goes low. Okay. Tangent also has undefined on either side. Okay. But it's a little bit different, right? Instead of 1, 0, -1, where's it going to start? Yeah, so tangent is going to start with a negative slope. Sorry, start low and go high, so it'll have a positive slope. Okay. And then what's the period formula for sine, cosine, secant, and cosecant? Yeah. Okay. And then what's the formula for cotangent and tangent? Yeah. Okay. And then there's also something that that is a little unique with tangents in the sense that the full period for tangents is kind of doesn't start at 0. So, well, it can start at 0. It just looks like it's broken up by the asymptote. So typically what I like to do is for all the other functions, we always start 0 and we add the interval, right? We add the interval to the right. But with tangent, to make it so that it looks like a full graph that we can recognize, I like to start the 0 in the middle. Let that be the starting x value. And then you subtract your interval twice to the left and you add your interval twice to the right. Okay. If you don't do that, it's okay. It's just that your graph is going to look like it's cut off by the asymptote in the middle. Okay, so if you do this, they will ensure that your graph will be more recognizable with the asymptotes on either side and the graph increasing from left to right. Okay, so all right, so your quiz tomorrow is going to be 4 graphs. It'll be, well, actually, it'll be 3 graphs and then one writing an equation. Okay, so but it'll be one of each. So you'll see a cosecant, a secant, cotangent, and tangent. Okay, so today we're just going to work through 4 problems. So we're just going to go through the odds. So 1, 3, 5, 7, and well, let's do 8 and we'll do 8 and 9 at the end, just so they're relatively quick and we can get those practice in. Okay, so let's start with number 1. Okay. So cosecant, we want to ignore the fact that it's cosecant to begin with and just think in terms of what? Sine. Yeah, so do everything from sine's perspective, and then at the very, very end, we'll bring in the fact that it's a cosecant graph. Okay, so treat it like a sine function. Okay, so first things first, let's rewrite this problem because we need that b value to be factored out. give you guys a moment to try that, and I'll follow up with some of the steps. Pretty okay with factoring out that 4 and getting that C value to be pi over 8? Okay, any questions about finding the period, finding the interval? So most all the functions, we're going to start at 0. Only tangent, or we're going to start at in the middle. We'll start at 0, and we'll keep adding our interval until we reach the end. We're moving to the left pi over 8, so we got to subtract pi over 8 from each of our original values. Cosecant, we want to think in terms of sine. We know sine starts at 0. Looks like amplitude is not going to change here. Okay, so again, we just want to pretend like as if we're sketching out the sine graph. At the very end, we can bring in the fact that it's not really a sine graph. There's no d value, so well, I mean there's no vertical shift, so we can just plot all these as original y values there. Starts at 0. Okay, now do dotted lines for these because this is not really the true graph that we're after. Okay, do you see where this graph crosses our d value, which in this case is 0? So wherever it crosses the d value, that's going to be where you know where to draw vertical asymptotes. Okay, vertical asymptotes will be all the intersections between your d value. I know we don't have a vertical shift yet, but next problem we're going to see a vertical shift. Wherever that d value intersects with your dotted line curve is where your asymptotes will be dropped. Okay, so we've done everything from a science perspective. We don't have the cosecant graph yet, but if we can get this part, then the cosecant graph is going to be the easy part. So now we have all these boundaries to help us help shape our cosecant graph. Cosecant graph will just look like parabolas. The asymptotes kind of gives you an idea how wide to make them, and then the peaks and valleys of your sine graph tells you where your parabola will kind of bounce off at those points. So here, I'm going to draw a parabola that's going to go right through or intersect with that vertex or the height and the peaks of my sine graph. So the graph in red is the true cosecant graph, but we have all those other things there to kind of help us figure out where that goes. Yes. I need to see where these points are, and I need to see your asymptotes. Oh, that's right. No. You don't have to graph any order pairs. Yeah, just the main ones. Yeah, just the main ones. Okay. Any questions with one? Yeah.
Wait, so why did we put the asymptote at I over 8? Where is the asymptote?
So the asymptote is wherever your sine graph crosses your d value. In this case, my d value is 0. So wherever it touches the dotted the x, or in this case the x-axis, that's going to be where cosecant will be undefined. So I'm going to drop vertical asymptotes there. But the next problem, you're going to get a d value that's different than the x-axis. So I'm going to have a horizontal dotted line, and where that horizontal dotted line intersects with my cosine graph is going to be where my asymptotes will be. Okay, good. Any other questions here with number 1? Okay, so we'll skip number 2 and go to number 3. I'll leave this here in case you need to look at that. So this one, -3 secant 2 theta, we're going to pretend like as if we're graphing the what? Cosine. Yeah, so do everything, pretend like it's cosine until the very end, and then we can bring in the vertical asymptotes and the secant graph. Everybody good with one? For number 3, there's no need to factor that 2 out because there's no horizontal shift. There's no C value. Okay, so secant is going to start, treat it like a cosine. Have a d value of 1, so I want to make sure this is now the center of my graph, the middle point of my graph. Okay, we're going to do plot these points like as if we're dealing with a cosine graph, but these are now no longer going to be y values, right? These are not going to be distance from my dotted line, my center. So that means at 0, I got to go down 3 units. Back to my dotted line there. Up 3. Back down. So I like to think of it from a visual perspective that, wherever the dotted line touches my d value is going to be my asymptotes. Or you think of it this way. If that looks, if you want a different way of thinking about it, then your vertical asymptotes will occur wherever there's zeros for your cosine graph, or wherever there's zeros for the sine graph. Okay, so that helps to to help you locate it in case you have trouble here. You know that it's going to occur wherever zeros occur on your secant or your cosecant. Okay, so we know they're vertical asymptotes at power 4 and 3 power 4. Now comes the easy part, right? You've taken care of all the hard parts. Now the easy part is just sketching those parabolas off the top and bottoms of your peaks and valleys. Okay, you can complete the graph if you want. It's just that I'm only graphing between 0 and pi, so that's why it looks like it's cut off. But if you want to finish off the graph, you can. Okay, any questions with 3? Okay, go to number 5. Start at 0, or not start at 0. That will get sure that you graph it. So that's well, we only want 2 on the left. We want 2 on the left, 2 on the right. This way you want to ensure that your graph will have asymptote, and then the graph. That's right. Which one? Yeah, this one's a little messy. Let me show you. Yes. I'm sorry? Yeah. Wavelength is a period. Sorry about that. Wording's a little strange. Okay. Number 5. So number 5, tangents. We have to make some adjustment, right? What's our period formula now for tangents? Pi over b. Okay. So, and then once you are ready to create your table, make sure that you start at 0 and then you subtract your interval twice on the left, add your interval right twice. Normally, I know we start at 0 and we keep adding our interval, but we do this so that the picture that we create is something familiar, right? Asymptote on either side and the graph will rise. If we start at 0, what's going to happen is your tangent graph is going to look like this. It's going to have a asymptote that's going to interrupt your graph, and this is not wrong. You can do it this way. It just looks strange. So that's why we like to shift it over so that we get something that we recognize. But cotangent is nice. Cotangent will start at 0 and do everything we're supposed to do. So only tangent, you want to kind of bend over backwards to make it look better. So just tangent. Everything else for tangent, right? Everything else, you start at 0 and move to the right.
And then we go left.
My guy, what are you doing? Man, that whole bit was really good.
I was like, what are you doing? With beard.
I'm for cotangent too.
Now this one is higher.
So it looks like for number 5, your period is going to stay as pi because there's not going to be a b value that's going to change it. Okay, so tangent is the strange one where you want your 0 to be in the 3rd slot, the middle, and then you can just subtract power 4 on both sides to get your starting theta values.
What are you gonna do? Make a paper white.
Okay, so tangent has the pattern of asymptotes on either side. And tangent has a positive slope. So we start low and we move up. Yeah. Question.
So for tangent's the only one where we start in the middle.
Yeah. Yeah.
But cotangent we start.
Cotangent start at 0. Cotangent start at 0. I'm sorry? Yeah, wavelength is period.
I thought it was NA.
That was from like 7th grade.
Okay, so this is what I have for number 5 so far. I have the asymptotes. I have the new d value. I move the graph down 2 and up 2 from 4. So I'm going from 2 to 6. And now I can sketch my graph. I have a positive slope.
Oh, I'm so right. I'm so sorry.
Okay. Any questions with number 5?
I think it's right. I realized I did it.
Really changed it.
What did you have it originally? Or you got that reaction? I can't bother. I don't want to talk to you anymore.
Okay.
It's my favorite thing ever. Mine isn't working. Every time I click on something, my entire computer runs. Why? Oh no, it never restarted.
That's the only one that.
You said we're just going for 9, right?
Okay.
Do I just add the
Yes.
and then you see the space?
It
just looks like it's kind of like.
Thanks for recording.
was like, you know, you have this look, you look at me like, yeah.
I didn't know you, but I had the right idea.
Guys, let me go over number 7 in detail. Let me know if you have any questions. So first thing, sorry. First thing is we want to be able to factor that 1/3 out. So once that 1/3 factors out, we got to ask ourselves 1/3 times what gives us pi over 6. So we're going to need pi over 2. So 1/3 times pi over 2 gives me pi over 6. So this is now my new A, B, C, and D value. Okay. Okay, so now that we have our B value, we can find our period, make sure that we have to adjust our formula here. We're still, remember, cotangent and tangent are both pi over B. So pi divided by 1/3 is same thing as pi times 3, which is 3 pi. Once you have your new period, make sure you go through your interval procedure. 1/4 times 3 pi equals 3 pi over 4. So cotangent, we start at 0. Okay, it's only tangent, you got to kind of shift your starting point to the middle. But here, we're going to start at 0. Keep adding 3 pi over 4 until you reach 3 pi. And then there's a phase shift, so we have to subtract by pi over 2 to get those new x values, theta values that we're going to plot. Cotangent has undefined on either side, just like tangent. But cotangent has a negative slope, 1, 0, -1. But what's going to change this here? Our graph is actually not going to have a negative slope.
it's because it's a reflection.
It's a reflection. So we multiply by -3, so all of a sudden, your graph is going to look more like tangent than it does cotangent because of the negative. Okay, so we have our D value. Guys. Okay. So we have our D value. We shift up 1 and down, sorry, we shift up 3 and down 3. And then we have our it looks like a tangent graph, but it's actually cotangent because of the reflection. Oh, sorry, let me go back here.
Oh my gosh, see it now.
Okay, any questions with 7? That's good. Yeah.
I didn't know. Just hearing about all we're doing this month.
No, because I was like you gave me the one. Wait, is it all we're doing? No, you gave me the one.
Is this all we're doing?
Yep.
Okay.
And then I read the thing and I saw it, and it was like you gave me the one that
I got
time
3.
when it was like asking for delta.
On number 9, I got.
Yeah, I know. It was like.
So you got this one, right? Cross multiply.
Yeah.
Divide both sides by 3 pi. Pi's cancel out. There's still a 1 up top, so it's 1 over 3.
I might hear.
I just canceled out the pies and assumed that.
Yeah, we still need that 1 there.
No, we're not.
So if it helps, if you want to put a 1 pi, that way you can cancel out, there's still that 1 sitting there.
Should be like, sorry, I can't.
Okay, any questions here? Okay, so tomorrow your quiz will just be 4 problems, very much like what you see here. We'll spend the first 5 or so minutes just kind of reviewing the formulas, make sure we know the period form, make sure we know the pattern. Okay, and then you'll take the quiz after we do a little bit of review at the beginning of class. Okay.